Let me introduce myself. I used to work at Google, then ran my startup FutureCam, which is a camera app. Then I worked as CTO of a different startup. I now work as a consulting CTO. Today we are going to talk about cohesion and coupling in software design. I'll use iOS and Swift to illustrate the concepts, but the concepts are independent of programming language. Let's look at the camera class that we have. This is like it represents the camera. And it has properties which are of two types. If you see here, one type of functionality is about configuration, another type is about capture. So zoom level is about configuring the camera, changing modes, adding an output to capture a photo, focusing and exposing, like tap to focus. All these are about capture. This is about, sorry, all those were about configuration. This is about capture. Again, focus mode is configuration, lens position, changing cameras from wide to tele. Again, this is configuration. This is a function that analyzes the current scene and automatically switches to the telephoto camera if it's going to work better. This is again configuration. Raw capture is about configuration. Adding a video data output to capture a video is about configuration. Shutter button pressed and released are about capture. Determining the settings to use for a good quality is about configuration. Metering or adjusting the exposure is again about configuration. So you can see that everything in this class divides into two categories. This is a violation of the single responsibility principle. This class has two responsibilities. And that means it has low cohesion. Cohesion is the extent to which the members within the class are related to each other. If you have a bunch of unrelated things in a class, it has low cohesion. Two things stuck together, like in this example. So what should we do? We should split it into two classes, a camera configurator class and a camera capturer class. And each of them has high cohesion now. So instead of a class that does two things, which has low cohesion, you have two classes with high cohesion. You can draw a diagram like this. Take an inventory of the responsibilities or the functions in the class, functions and variables and so on. And use a different color for different responsibilities. So if you have a shopping cart in an e-commerce store, let's say, a lot of the functionality may be about discounts and coupons and if I use this coupon, can I use another coupon? Some coupons may be mutually exclusive, some may not be. Some may have limitations, right? You can use this coupon only if your order value is more than 1,000 rupees. Or you can use it only once in a month. So one set of functionality may be about discount calculation. Other set may be charging the card or the debit card or Paytm or Bitcoin, right? So when you do this exercise with the shopping cart class and you choose one color for each functionality, say you choose red for discounts and green for placing an order. Now you have a box with two colors in it, and you shouldn't. A box should contain only one color. In this case, after splitting it, this box is green and this is gray. So this is about cohesion. High cohesion is good, low cohesion is bad. One sign of low cohesion is that you cannot come up with a good name for a class. This is not actually a camera. If the phone has three cameras like wide angle and ultra wide and tele, there is still only one instance of this class. So it's not really a camera. What is it? This comment says it's a wrapper around AV foundation, but it doesn't do a good job of that either. because a lot of classes bypass this class and directly access AV foundation. So it's not a wrapper. It's not a camera. So when you can't come up with a name, that is one indication of low cohesion because it is a dumping ground. Another indication of low cohesion is you can't explain it to somebody else. If a newcomer joins your team and asks, what does the camera class do? You can't explain it. Whereas if you take something that has good cohesion, for example, time-lapse mode, it records a time-lapse. Video burst saver, when you record a burst of photos by holding down the shutter button, this class saves all of them. I don't even need to click the class and open it to describe it. In fact, you probably don't even need to ask me because the name is self-explanatory. So the third indication of low cohesion is that you can't form a good mental model yourself. When I work with this code, I always keep looking for a function. Is it in camera? Is it elsewhere? That's because there's no logical purpose to it. On the other hand, if I need to look for code that saves a burst, I never have any confusion. I never have to check multiple classes to find what I want. I know it's here in the video burst saver. So these are some of the indications of low cohesion. You can't come up with a name. You can't describe it to a newcomer on your team. And you have to search multiple classes to find what you want. You can't form a good mental model yourself. These are the three indicators of low cohesion. Let's move on to the other property, which is coupling. Coupling is the extent to which two classes are connected. To describe that, let's talk about modes. A camera has different modes like time-lapse, burst, long exposure, light trail, photo, video, etc. Each of them is represented by an instance of mode, and all of them inherit from mode, the superclass. And this class works closely with the camera. Too closely, in fact. If you make a list of the calls that are being made from one class to another, mode invokes all these functions on camera. See, set device is recording, set is recording, add video, all of these calls. Camera invokes the following on mode. So if you were to present this information graphically, it looks like this. Mode makes 8 different calls to camera, and camera makes 4 calls to mode. This is an indication of high coupling. More the lines between the classes, higher the coupling. The problem with coupling is, firstly, you can't reuse one class without the other. Secondly, when you add a function, you don't know whether to put it in camera or mode. It's arbitrary. Some functions are here, some functions are there. So somebody who wants to look through it has to look in both places to find what they want. The code is also harder to understand because execution bounces from this class to the other. So these are problems or indications of high coupling. One more indication can be when you set up helper functions like this in mode, which access properties of camera. Why did you set up this? Because you are using multiple members of camera, and that's a bad idea. So when you have two classes with high coupling, they should really be one class. So when you identified a problem with cohesion earlier, the cohesion was low, the solution was to split it into two. Now when we identify a problem with high coupling, the solution is to combine them into one, because logically it does only one thing. There earlier we talked about the camera class having double responsibility. It does both configuration and capture, double responsibility. Now we are talking about each class having half responsibility. The responsibility is split between two classes, only one responsibility. So each class has half a responsibility. That is also bad. This is a principle you can use irrespective of programming language. Whether you are writing object-oriented code, functional code, any other kind of code, this is a general principle of programming or software design. I think there are tools that help you analyze this as well. But if you take a step back from your day-to-day work and look at the code and identify problems. So for example, let's say you're looking for a function. You look in two classes. If you observe what you're doing, if you create a second version of yourself, looking at you and saying, what is this guy doing? The voice in your head should say, hey, this guy is searching. Why is this guy searching? That's an indication of a problem. He doesn't know where the function is. So what does that mean? If you follow up on these logically, right, you get these signs, and we tend to dismiss these signs because we are in a hurry to build a feature. But if you stop and listen to these signs, the code base is speaking to you. It's telling you what its problems are. If you found this helpful and would like to be informed when I post more videos, subscribe to this channel. If you have any thoughts on these, leave a comment. Let's learn from each other. And if you'd like me to work with your team in improving your code quality, there's a link in the description.